Okay, Apollonia, do you mind reading number 16? Okay, so in letter A, it asked, and this is something you have to highlight or circle because it's unusual. This is something we haven't done. It's asking for you to calculate the present value factor. It means nothing other than it's the factor, which, let me explain it even further. That number is what you find on those charts, those present value charts, whether it's the annuity or the lump sum. Those numbers on those pages are called factors. Okay, there's nothing more than that. So in letter A, how do you calculate a factor? It's this calculation here, amount to be invested over annual net cash flows. And what I want you to realize is if you look at that formula, does that stand out to you and remind you of another calculation? So the amount to be invested divided by annual net cash flows. And if you think about it, that is cash payback. How much are you going to put into it? How much is it going to push out in cash? And that'll tell you how many years. So it's not another formula to memorize. It is the same thing as cash payback. So knowing that, it calculates out to 3.785. When you go to, and you can do this right in your chapter, go to that exhibit 5 in your textbook, in your chapter 26. If you look, and what you have to do is, it was for 6 periods. So in letter A, how many, are in the problem, it said the present value for the annuity for a buck for 6 periods. So what you do is you have to go to exhibit 5 and you go down to row 6 because it's 6 periods, and you need to go across that line until you find 3.785. Please do this with me if you're not. So then if you have that exhibit in front of you and you're going across 3.785, and then when you find it, you look up or you arrow up, and that lines up to 15%. So what it's telling you is this problem or this exercise, this alternative is going to produce a rate of 15%. Okay? Any questions on number 16? Because now we're getting into the internal rate of return. So we're going beyond the present value, knowing is it positive or negative, but exactly how much. So I'll just scroll down here. So for number 19, this is kind of puts it all together. 19 is a good one for you to review. So I'll let you read number 19 first. Perfect. Okay, so first in part A, we have to calculate the present value. And can anybody tell me why can we use the annuity table in Exhibit 5? Why can we use that one versus going to the present value of $1 and calculating it every time? Can anybody tell me why we can use in part A here, if you see, all we have to do is just do it one time. We only have to do it one time compared to, I'll show you here up here. Like in this exercise here, number 7, notice how we had to calculate it 4 times. It was 4 years. And the difference is right here. Can anybody see that? It is a different cash flow for every year. So then you can't use the annuity. The annuity tables have to be the same dollar amount all the time, every year. So in this case, it was $35,000 for all 8 periods. That's nice. So you can take that factor found in Exhibit 5 times that 35,000, and that's the present value of the cash flows. Apollonia said that the amount to be invested is 186. So notice here, for the first time in all of our exercises, we have a negative net present value. So that means, going back to the question, is it 12%, less than 12%, or more than 12%? Of course, in this case, it has to be less than 12% because it is not 0 or positive, right? If this was 0, meaning that this was 186, this is 186, so it's 0, that would mean it's exactly 12%. If this positive number was like 14,000 plus, that would mean it's greater than 12%. Okay, so now we've calculated net present value, but now the question is, how far below 12% are we? If it's 11.99%, we can say, well, that's basically 12, we're good with that. But it could be something far different. Well, before you go to calculate the internal rate of return, you have to know the factor. And again, it's cash payback. Put the amount to be invested, 186, divided by, that's the annual cash flows, 35,000. So that is 2 answers. It will take us 5.335 years to pay itself back. Or what we're really trying to calculate is the factor. It's 5.335. So now you go again to Exhibit 5, and you have to go down to the number of rows because that's our only known, and it was 8 years. So you go to row 8, you scroll across, and when you find that factor of 5.335, and as far as the test is concerned, these exercises, it's always going to match up just perfectly, which is not realistic, but that's how it works for this class. We're going to get to the 5.335 factor. You look up, go to the arrow up, and you'll see that matches to 10%. So what it's telling us is this investment doesn't do 12%, we knew that, but it's 10%. So it calculates an internal rate of return of 10%. Questions on number 19? Anybody? Okay, then we'll go to 21. And 21, we'll just do a big picture overview so that you can see. This is, again, it's just net present value, just a good practice. It shows you here what's the big deal here. Well, look at all the cash flows are different, right? All of them are different. So then we have to use that present value of $1, that first table, and you go all the way down, calculate it every year, year 1, year 2, year 3, year 4. This second one in year 4, that's the residual value in the problem that they're talking about, that it's what they get back. So we're trying to compare these 2 options, the processing mill and this electric shovel. Which one is the better investment? Well, this one shows cash flows of $1,370,000. This one is $1,003,000. We have the same amount to be invested in each investment alternative. So the net present value on the first one is 196 versus 179. So we can say this, they're both positive. They both look to be good. I'm trying to remember on this problem, if I scroll down, no. So we don't go through the work of calculating what the actual rate is. So in this one, they only ask for the present values. Of course, it looks as if the processing mill will have a better rate, has to, right? Because it's nearly $20,000 greater from a present value standpoint. But the lesson to learn out of these two scenarios is you can't use the annuity table because it's different cash flows for every year. Anybody have questions on these two alternatives or what we're trying to do here for net present value? It's just, and if you look, if you set it up the same way every time, you'll be consistent and you won't forget a step. The only difference between the two that you've ever seen is, in this case, notice we're calculating all kinds of calculations before we get to our total compared to what we invest in net present value, as compared to just the previous problem where if it's a same cash flows every year, then you only need to do one line because we can use the annuity table. Now you could certainly go back and use the present value of a lump sum table and just do it 8 times, and you'll still get the same number. But since it is the same annual cash flows, you can just use the annuity table. So there you have that same total, but then compared to what you would put into it to a net present value. So these net present value calculations, if you set them up the same every time, you'll not confuse yourself. Any questions on 21? Okay. And then in problem 1, you correct me if I'm wrong, Apollonia, but I think this problem asks for 2 things. 1, what is the average annual rate of return? And then the other part of the problem they want you to calculate is the net present value. So thank you. So this one up here, average annual rate of return, does not factor in the time value of money. Letter B, it does calculate the time value of money. Okay, so let's first make sure we remember average rate. And what's the deal? Average is why we divide it by 5. Rate would mean that we're looking at income, annual income. Okay, so our numerator, right? Our numerator is our average annual income. So this was the total divided by 5 years. The $75,000 is the cost of the investment. There was 0 residual value. So then you take 75 plus, make sure you highlight that, that's odd, plus the residual divided by 2. So now we've got our annual average divided by our the average of our investment is a 30% rate of return. Okay, they have to give you these numbers. You can't come up with this on your own. It's not a calculation. They have to tell you what the income is. They have to tell you what the investment cost is. Okay, so then knowing that it was a $75,000 investment, we can take that to letter B when we try to calculate net present value. Now this one, they actually did it in one problem, but there's 2 calculations here. And what they tried to do was they put the present value of those cash flows, the present value of the factor for $1 for all 5 years one time. So they just put it here. But then what they did is, and this, I think they could have made this a little clearer. You could have done this twice and I think made it clearer. So they put the cash flows here for the front end loader. They put the cash flows for the greenhouse here. Now, you'd say, well, look at here. These are the same for all 5 years. You're exactly right, and you could have done the annuity table. Unfortunately, we could not use the annuity table for the front end loader. So what they did is just to prove to you that you can still use all the factors, even if it is the same, you'll get to the same answer. But we have to for certainly use the different factors for each year when it is different cash flows every year. So then you take 0.893 times 40,000. The present value of that is 35 right here, 35. 0.893 times 26,250, 23,441. Just want to step back here a minute just so you see something, and you'll learn a lot more of this when you take managerial finance, but I just want to make sure that this makes sense to you. If you're going to get $26,000 in a year from now, does that make sense that today it's worth 23? It's not too far off from 26 because it's only a year. But if you're going to get 26,250 in 2 years, it's worth even a little bit less today because it'll be 24 months before you get it, or 36 months versus 60 months. If you're going to get 26,250 in 60 months, 5 years, that's worth $14,884 today at 12%. I think that's interesting to see, and you should see that it's worth even less the further out it is versus the closer it is to today. Okay? I'm sure that makes sense. So then what would, you bet. So then you see the cash flows, they're both the same. However, when we compare our different cash, when we compare our net present values, because they were different, we have 99,009 versus 94,006. And it's because the time value of money. This just happens to be the same, but notice here, we're getting 40,000 in a year versus 26. So that's going to have a bearing on that 99. Again, the investments are the same. So in this case, which one is the most attractive? The front end loader. Not by a lot, $5,000 or so, but it's more attractive. Now, the question you'll get on your test is it greater than 12%, less than 12%, or equal? In both, it's greater because these are positive and not zero, certainly not negative. Questions on 1A? Cool, good, you bet. And anybody holler if you got questions. All right, so then let's go to 2A. And 2A, it appears, let me make sure I got this right. Yes, 2A, we're just looking at, two things, cash payback, and again, the net present value. Well, cash payback is, again, this one up here, no time value of money, no time value of money. So all they're saying is, how many years does it take to pay itself back? Well, we know it's a $900,000 investment, according to the text. Each year, it pays $450. You're a rocket scientist if you can figure that out. That means it takes 2 years. Okay. Retail store. Look at there. How nice again. How 500 1 year, 400 the next, 2 years. So of course it's very, very, very unrealistic that it's nice, beautifully round numbers, each adding up to 900,000 exactly in 2 years. That's not the way it works, but it's trying to get the point across. Cash payback. How many years of cash does it take to pay itself back? Net present value, again, this is similar to the previous problem where what they do here is notice very clearly no cash flows are the same. So that's different every year. Same with this one. The two comparisons, plant expansion or the retail store expansion. all different cash flows each year. We can then just go to our present value tables for the dollar and just list it all down for both scenarios. Just put it here one time, put the two different cash flows down, and then do your calculations. 0.870 times 450, 391. 0.870 times 500, 435. You calculate it all the way down. We have two net present value calculations, or excuse me, for just the cash flows of $1,200,000, $1,200,000 again. There is a $900,000 investment. Then we look at and say which one is better, not by much. On both scenarios, the plan expansion is just $5,000 less in net present value. So in both scenarios, we can say it's meeting our hurdle of 15%. We don't know how much over 15, but we know it at least met our definition. This is something that you'll do in finance when you want to look at, should we or should we not purchase this investment? And when I was a CFO at Hague Companies, and we look at purchasing a hotel, should we take this hotel on or not? You can have the Taj Mahal built, and it looks great, and it has, all of the amenities needed. However, if it doesn't produce cash, the investment is worthless. We never bought a hotel because we thought it looked pretty. We didn't buy a hotel because it had the right flag, meaning franchise. We bought it because it returned cash on the investment. So what you do is you need to calculate what you believe are going to be your cash flows. And you're talking a hotel, and it's a large investment. You don't expect it to pay itself back in 1 year, 2 years, 5 years. It pays itself back in 5 years. Tell me where that's at. We all need to buy that. But what we want to know is it making our interest that we demand? So you calculate what these are guesses, right? I mean, it's a very sophisticated guess, but if you're on a corner, you're on the corner of 41st Street, and we manage those hotels there, 41st Street and I-29. Now there's two of them there, two Marriotts. It used to be just one. When we had it, it was a Radisson, one Radisson. Now they tore down the Radisson and they built two Marriotts. But that's all great, and you can come up with these cash flows. But then 2 years from now, your competitor builds a Hilton right across the street. That is going to stress these cash flows. And of course, that will make a difference whether you do or do not earn your 15%. So these are educated guesses, right? These right here, these are your educated guesses. You take it times your present value numbers, and you know exactly the check that you have to write to buy that hotel. Then you can say, okay, is it meeting our definition? And let's just be frank, 15%, that's high. That's very high. You don't earn that today. But I should say this. We could have earned that prior to this COVID, right? The market was doing phenomenal, and then everything has kind of taken a pause. I think we'll get back there. All right, then problem 4A. 4A combines both, and this one is a very good problem to look at because it looks at the two calculations that calculate the present value of a dollar. It considers the time value of money. So the first one is wind turbines, and then this biofuel equipment. Again, nice. You love it when you see it's the same cash flows every year, because then you can just do it one time. 280 for this one. Take it times that factor. And I should point something out so you see this. You probably noticed this already. If it's an annuity, the factor is always over 1. If it is not an annuity, all your factors here, notice this is not an annuity factor table. They're all below 1. They're all below 1. So if it's an annuity table, you know you're looking at the right one. If it's over, they have to be more than one. So in this case, it came out to a present value, a net present value of 82,000. So we know it is positive. We know then if this was based on 6%, we've exceeded 6%. On the biofuel, it also exceeded it by 128,000, so it also exceeded 6%. Now, something that I need to have you make sure you identify, highlight, make a big deal in your book, because this is something that we don't do anything with it ever. But in this problem, in letter B, it asks you to calculate the present value index. So when you are doing Cengage, every time it's going to be calculate the net present value, calculate the internal rate of return, even probably calculate the present value factor, as you see in number 2 there. But in letter B there, it says index. And all the index is you taking the net present value of your cash flows. So like here, the present value of your cash flows, 970, 200, divided by what you're putting in there for an investment, your cash, 887, 600. So this is just the present value index. The reason I'm making a big deal about it is I want you to see that this is different than that. Okay, so just keep that in mind, nothing to worry about. Number 2, it asks you to calculate the present value factor. And we remember by saying that factor is really cash payback, amount to be invested divided by the annual cash flows. And we saw up here, the annual cash flows was 280, amount to be invested. So we can say this is the amount to be invested, 887 divided by the cash flows, 280. It takes us, it gives you 2 answers, 3.17 years to pay itself back, or that is the present value factor. It means nothing other than you take that factor, you now go to your chart, the annuity table. We knew it was 4 years. So you go down on the left-hand side, 4 years, scroll across, you're in Exhibit 5, scroll across, and when you find 3.170, you hit it, arrow up, and you'll see that the wind turbines is 10%. 3.037 is 12%. Step back and think about that. Does that make sense? Well, it should, because it takes 3.17 years to pay itself back, or 3.037 years to pay itself back. Faster. That would be a greater return, a greater rate. All right, questions on 4A. Anybody have any questions on 4A? I will stop sharing my screen here a minute. I don't know if I'm back or not. Apolloni, can you see? Am I back? All right. Hey, good morning, Kayla. I didn't see you join us. Any questions on the exercises and problems that we did today? I know. That's a very good point. There's a lot there, but every time we've done those exercises, I try to be like very consistent that we do it the same way every time, and the solutions are kind of laid out that way. So I would always set up those problems kind of the same way, knowing that. So you have your 2 non-present value methods, cash payback and average rate of return. Cash payback, remember we're only looking at using cash flows. Average rate of return, average, and we're looking at income, which includes depreciation. That's the big deal there. And then you got your net present value. And really the only thing you have to remember there is, well, two things. Set it up the same way every time, same format. And you're going to need to know, is it the same cash flows every year or is it different, which will determine which tables you use. And then you get to the internal rate of return. And before you can do anything with the internal rate of return, we first have to calculate the factor, right? We need to know the factor, or calculate your cash payback, right? Factor. And then you can do, go to your chart and go down for the number of years, scroll across till you find that factor and look up, and that's your interest rate. So that's really the end of chapter 26. Because I'm getting old and forgetful, did I send you the review sheet yet for 22, 25, and 26? I'm thinking I did not, but anybody remember seeing anything like that? It would be a little early for me to send that anyway. 22, 25, and 26. So I'll be sending that out here in the next day or tomorrow at the latest. But what I would tell you is this. So we're pretty much done with 226. You guys made it. Good job. And I am going to send out another invite for Wednesday. And really what I'll do for that time is, well, I'll go over anything, review for 22, 25, and 26. That's one thing I can plan on doing. The other would be if there's any exercises that you want to go over. If there are any, shoot me an email and I'll make sure I have those covered. But that's this week. And then we've pretty much finished this course, so that's what I'll use for Wednesday. You don't feel you have to log in, but that time is totally for you. That's all I have for today, folks. You guys have done well. Any other questions that I can help you with before I let you go? That's totally fine. All right. Hey, well, I will let you guys go. Have a great Monday. And I'll probably see some of you on Wednesday. Take care.